Right, welcome. Today we are going to be continuing with the completed square form, just going over a little bit more of an advanced example or two, and we're going to be touching on the quadratic equation as well. Now, we're going to start here with this example. They're asking us to factorize this equation. Now, I've gone here and I've completed the first step here, which is to open up the square form as we normally would do, take out the 6, factorize the middle equation part that's left, and add in the minus 1 over 4. And then we've got c on the other side here. But now we need to complicate this a little bit more. We don't want this c on the outside. We want c on the inside. So how do we do that? We simply divide c by the factor we've taken out by a. So that ends up looking like 6 x minus 5 over 12 squared minus 1 over 4 times 5 over 6 squared, and then because negative 6 divided by 6 is negative 1, add minus 1. And we close the bracket. Right, so now we've taken this outside c and we've placed it into the main equation. So it's added here. And when you do the addition for this, you come to figure out that the consonant number here, let me just write out the whole thing. It becomes negative 169 over 144. Now, notice something special about this number. It is a square root. You can square this, you can root this number, right? Perfectly. Now, Now, what does that enable us to do? Well, we talked about our equation earlier, remember, which was a squared minus b squared is equal to a minus b multiplied by a plus b, right? Now, how do we get this equation that we've got here into this a squared minus b squared form? Well, we've got our first term here, a, which is this first part, x minus 5 over 12 squared, and we've got our b squared, which is 169 over 144. But this isn't in square yet, so let's square this, right? This goes to be, the square root of 1 is 169 over 144. So we're just going to go minus 13 over 12, right? And that's our b term. So let me just add this in here. Let's just delete this. Add another. Okay, so our b term. Let me write out our a term. Right, so this is our a and b terms. Let me see if you can see that. Right, you can. So practically what we're going to be wanting to do here is we're going to be wanting to slot them into this formula quite simply, right? All it does, it comes out to a minus b. So we've got x minus 5 over 12, which is our a, and now a minus b, so minus minus plus 13 over 12, right? And this is our first bracket. In our second bracket, we've got a plus b. So we've got x minus 5 over 12. And then we've got now minus, because it's plus a negative, minus 13 over 12. Right? Okay, and now from here you can see that these denominators are the same, so we simply add them up pretty simply. So we come out to x plus 8 over 12, which you may have guessed already. We're going to simplify further later. And then this one is x minus 5 over 12. Sorry, this is x minus 18 over 12. Right. Which simplifies down to x plus 2 over 3. Yeah. Right. And x minus 3 over 2. Okay, now what we do from here is, this isn't finished quite just yet. You can't just add these as your roots. Now what you need to bring back in is the 6. This is our a term from the beginning, if you remember, all the way up here, the 6 here. Right? So 6x plus 2 over 3, and then x minus 3 over 2. Okay, and now I've got an equation to work with, this here. And it's a little bit inconvenient because of how to multiply this in. So the easiest way to do that is to split this 6. And what we're going to do to split that 6 is we're going to go 3x plus 2 over 3, right? And the second part of that is the 2, right? 6 over 3 is 2. 2, and then we're going to add in x minus 3 over 2. Okay, now I've got this more convenient form of multiplying in, as the denominators match, right? And what this multiplies out to is 3x plus 2 multiplied by 2x minus 3. And now you can see this is in your factorized form. So this is a factorized equation. And you can see here 3x is equal to negative 2 and 2x is equal to 3. So from there you can find out your x values and therefore your roots. This is your root equation. Right. Now this is a little bit theoretical. So what is the more practical application of this, right? We can go over here to this pane. And let me just set this up really quickly. Right. Well, let's take a graph that they're going to give you. Okay. And they're going to go here. They're going to give you the point 4, and they're going to give you the point 2. And they're going to ask you, find the equation of this graph. Well, we can go back into the square form. At the end of the square form, what does the square form give you? It gives you the roots. What are the roots? Well, the roots are technically the intercepts of x. So what are x-intercepts? We've got 4 and we've got 2. So what would that mean? That would mean x minus 2 and then x minus 4 is our base equation, right? Because this is how you achieve your roots. This is the equation that it will give you. And you can multiply that out if you like. So that goes to x squared minus 6x plus 8, right? Pretty bad 8. There you go. And that would be our equation for this line. You can just leave it in this form here if you like, but this is the fully expanded equation. So that's a more practical application of when they're asking you how to find the equations of a graph. Now let's do another example quickly. Right? I'm going to give you a little bit less information. We're going to have a parabola going through here, an axis of symmetry, and they're going to give us the y-intercept, which is 5, and the axis of symmetry, which is -1. Right. Now, from this, how do we get what we want? Well, we know that the axis of symmetry, this is the x thing, so that's -1, right? And we know the y-intercept, which is 5. So we know from the axis of symmetry, right, in completed square form, x plus 1 squared must be equal to 0 when x is -1, right? And this is the first part of the equation. To get to this number, we need to add a couple things into this mix. So let's first expand this out. This goes out into x squared plus 2x, and then this last constant, this c, is not relevant with this plus 2, right? Remember, c is always equal to the y-intercept, so c is equal to 5. So in this case, plus 5. X squared plus 2x plus 5 is the equation for this parabola. And you can see how the application of the completed square form is kind of useful in order to find and manipulate equations. Okay, so from here, I think we're going to continue on, and we're going to talk a little bit about the quadratic formula. I'm just going to open a new equation 9 here. So what is the quadratic formula? Well, the quadratic formula is minus b. I'm not sure if the software will allow me to do this, but okay, plus minus root b squared minus 4ac. Okay, and then this is all over 2a. I hope this is going to give me what I wanted to. Not quite. Let me try this again. Maybe if I erase the spaces. We're elongating this root. Maybe if I do this. There we go. Not quite. Yeah, that's right. Okay, so we get this. This is the quadratic formula. And this is derived from completed square form. If you go back into the completed square form, you can rearrange the formula into this. Now, what does this allow us to do? Well, this allows us to find the roots of all quadratic equations. And the reason it's more efficient than the completed square form or simply finding the roots yourself is it can use rather large numbers sometimes in quadratics, and this just allows you to get the answer without having to go through all of the pain of factorizing it. Now, there are a couple other special things about this equation that they can tell us. And this just gives you the roots or the x-intercept, right? And the special things that this can tell you are whether or not the line has roots. So remember, going back to the paint. An equation, a parabola doesn't necessarily have roots. It could have a line that goes like this. It doesn't touch the x line, so it has no x-intercepts, right? And how do we represent that in the equation? Well, in a root, if the inside of the root is negative, that means that it is not a real number. It doesn't exist, right? So in an equation where there are no roots, the root inside here is negative. So when you come out and this number in here is negative, that means that this equation has no roots, which means that this parabola has no roots. And that's the majority of the quadratic equation. This is the main thing it tells us. There are a couple other little factors that I'll go over in the next video. Thanks.